and welcome. In this session, we're going to discuss about instruction format. Today's topic, we are going to discuss about different instruction format. So we have 4 instruction format: 0 address instruction format, 1 address instruction format, 2 address instruction format, and 3 address instruction format. So define instruction format. A computer performs a task based on the instruction provided, isn't it? So instruction is nothing but an order given to a computer processor by a computer program. Computer program এর মাধ্যমে আমরা যেই ধরনের কমান্ডস একটা কম্পিউটারকে দেই ওইটাই হইতাছে আমাদের ইনস্ট্রাকশন. At the lowest level, each instruction is a sequence of zeros and one. ঠিক? At the lowest level, all the instruction are sequence of zeros and ones is nothing but binary. Instruction in computer comprises groups called field. The instruction are comprises of different groups in a computer. এটা different group এ ভাগ করা থাকে. This field contains different information as computer. Everything is in zeros and ones, so each field has different significance based on which a CPU decides what to perform. Based on this instruction, CPU decides that what to perform. Okay, the most common field, these are the field: operation field are the addition, subtraction, these are the things is performed inside the ALU. And the address field means different variable or operand is stored in a memory. So address field define the location of that particular memory. Then mode field, which specify how operand is to be found. Operand টা কিভাবে আমরা খুঁজতে পারি না, ডিফারেন্ট লোকেশন অপারেন্ড থাকে, তো মোড কোন পদ্ধতিতে আমরা এই অপারেন্ডটাকে ফাইন্ড আউট করতে পারি. নেক্সট, zero address instruction. Now coming to the zero address instruction, there is no address is located. Okay, it has its definition. The stack based computer does not use the address field. See here we are not using any address field, it is based on the stack. So here written as push a means we have to insert a operand to a stack. Initially stack was empty, so where we are going to perform this insertion operation? At the top. So at the top the result will be A only. Next we have to push B, where we have to push B at top. Now we have to perform this operation. This is called multiplication. Okay, asterisk, this is called multiplication operation, where we have to perform. These are the two operands. In between two operands we are going to perform the multiplication operation. This is called infix. Okay, so when operand in between two, when operator in between two operand is called infix. See, this is the operand, and if in between a operator is used, it is called infix. যখন ঠিক মাঝখানে আমরা কোনো একটা অপারেটর ইউজ করব তখন এই এক্সপ্রেশনটাকে আমরা কি বলবো? এই এক্সপ্রেশনটাকে বলবো ইনফিক্স. ওকে, if it is postfix means like this: a b, the operand first, then the operator. Okay, now stack based computer does not use address field. See, stack based computer does not use address field in the instruction. To evaluate an expression first we have to convert reverse Polish notation. Here is the expression. Okay, here is the expression given in infix notation. So this expression is to store inside the x. Now we have to convert this into postfix. In my previous video I have already discussed how to convert a infix into postfix, and postfix to infix, then infix to prefix, then prefix to infix. So these are the conversion I already have done in my previous videos, so keep watch that videos. Next, now we have to convert this postfix to infix, this infix to postfix. So we have converted this one. Now here a, we have to push a inside this stack. See, these are the things I am doing here. Okay, so we have to push, initially we have to push a, so here. Next B, next we have to push B. Okay, Next the addition. See, next addition operation, add. Next is add. So here we have to add at top. So this A and B between the addition operation, A plus B. Okay. In between A plus B. Now we have to push C. So here is C. Now we have to push D. So here is D. Now we have to perform addition. Again we have to perform what? Addition. See, addition means C plus D. Here will be C plus D. Now what operation? Now this is the multiplication. Multiplication of these two expression. Okay, multiplication of these two expression. The ultimate result. The end result will be A plus B A plus B asterisk C plus D. This will be the result. Got it? This will be the result at the top. This will be the result at the top. Now we have to insert it, this expression to X. So we have to pop. Now we have to pop this. Pop means deletion. Deletion at top. Okay. Now we are assigning this top inside the MX. Now here is one address. Now here is one address instruction. In one address instruction we are using accumulator. Okay. This is the implied accumulator register for data manipulation. One operand is in the accumulator. See, CPU already inserted one operand into the accumulator and other in the register or memory. Okay. Implied means that CPU already knows that one operand is in the accumulator. If there is a two operand, one operand is automatically inserted in the accumulator using one address instruction format. See, here is the opcode, here is the operand and address of the operand, and this is the mode. Now we have to load A. Here we are loading A, this A, where? To accumulator. See, automatically it will be inserted to the accumulator. Next, add B. We are adding B. See, we are adding B to this accumulator because this accumulator contains the operand A. A plus B will be stored inside the accumulator. Now, next store T. We are storing the result. This addition operation is stored inside the accumulator. Now we are storing the result to the temporary register. এখন আমরা কি করতেছি, accumulator এর মধ্যে যেই রেজাল্টটা স্টোর ছিল ওইটাকে আমরা টেম্পোরারি রেজিস্টারের মধ্যে লোড করলাম. নেক্সট, লোড C. Now we are loading C inside the accumulator and add D. Same process. We are adding D to this accumulator because this accumulator contains the operand C and result will be assigned to the accumulator. Now multiplication. Multiplication T because accumulator already contains the result of C and D. Now T is the temporary register. Temporary register stored the addition operation. Here is AC into empty. This T contains what? This T contains A plus B expression and this accumulator contains C plus D expression. Now we are moving the result of accumulator inside the MX, means this expression. Understood? This expression we are assigning to this operand X. Now here is our to address instruction. Okay, this is the common in commercial computer. Okay, it is frequently used. Here to address can be specified in instruction. Previously we have seen only one address. Now we can specify two address. One is destination, another one is source. Okay, one is destination address, another one is source address. Unlike earlier, in one address instruction the result was stored in the accumulator. Previously what we have done, we have done the results or every operation we are automatically storing inside the accumulator. Here the result can be stored at different location rather just the accumulator. Here we required two operands. One is destination address, another one is source address. Okay, now see, here destination address can be contains operand. Okay, so move A into R. Okay, we are moving this R1 and R2 are the register and this M is the memory location. Okay, we are moving this operand to the register R. Next, add B. Okay, add B means B is adding with R1. See, R1 already contain operand A, R1 এর মধ্যে already operand A আছে এবং জাস্ট আমরা R1 এর মধ্যে বিটাকে কি করলাম, অ্যাড করে দিলাম। অ্যাড করলে রেজাল্টটা কোথায় স্টোর হলো, R1 এর মধ্যে স্টোর হয়ে গেল। ঠিক আছে, নেক্সট আমরা কি করতেছি, মুভ অপারেশন। উই আর পারফর্মিং মুভ অপারেশন। মুভ C to R2. Okay, similarly C operand is assigned to R2 register, then D is assigned to R2 register. Okay, this is the add operation. So R2 plus D, the result will be stored inside the R2 register. Next, multiplication R1 into R2. R1 contain the result of A plus B, R2 contain the result of C plus D. Then this multiplication will be assigned to R1 only. Okay. Next, move. We are moving or we are assigning R1 inside the X. Understood? So this operation is done in to address instruction. In to address instruction, what we have done in to address instruction, আমরা দুইটা address use করছি। একটা হচ্ছে কি আমাদের সোর্স অ্যাড্রেস, another one is destination address। এখানে আমরা কি করছি, R1 and R2 দুইটা রেজিস্টার নিছি, R1 and R2 দুইটা রেজিস্টার। ফার্স্ট আমরা কি করছি, অপারেন্ড এটারে মুভ করছি R1 এর মধ্যে, দেন অ্যাড করছি। R1 এর মধ্যে অলরেডি কি ছিল, A ছিল। নেক্সট আমরা কি করছি, অ্যাড অপারেশন করছি। অ্যাড অপারেশনের রেজাল্ট আমরা কই স্টোর করছি, R1 এর মধ্যে স্টোর করছি। সেম প্রসেস আমরা করলাম এখানে। তারপর আমরা কি করছি, মাল্টিপ্লিকেশন অফ R2। সি হিয়ার আমরা কি করছি, মাল্টিপ্লিকেশন করার পরে রেজাল্টটা কোথায় স্টোর করছি, R1 এর মধ্যে স্টোর করছি। R1 এর R2 মাল্টিপ্লিকেশনের রেজাল্ট আমরা R1 এর মধ্যে স্টোর করছি। নেক্সট আমরা কি করছি, R1 এর মধ্যে যে এক্সপ্রেশনটা ছিল এটাকে আমরা কি করছি, অ্যাসাইন করছি MX এর মধ্যে। নেক্সট হিয়ার ইজ 3 address instruction. This 3 address instruction field to specify a register or a memory location. Okay, to specify a register or a memory location, program created are much shorter because we are using 3 address. See, 3 address 1 2 3, 2 source, 1 is destination, but the number of bits per instruction was increased. প্রোগ্রামের সাইজটা তো ছোট হয়েছে, প্রোগ্রামের সাইজটা দেখো অনেকটাই ছোট হয়ে গেছে, কিন্তু আমাদের ইনস্ট্রাকশনের সাইজটা অনেকটা বেশি হয়ে গেছে। That means the size number of bits per instruction is increased. This instruction make creation of program much easier. This instruction make creation of program much easier, but it does not mean that program will be run faster. এটার কথার অর্থ এটা না যে প্রোগ্রামের সাইজ ছোট হয়েছে that means প্রোগ্রামটা তাড়াতাড়ি রান হয়ে যাবে, এমন না। ঠিক আছে, নেক্সট, now instruction only contain more information but each micro operation, okay, will be performed in only one cycle. See, here is the expression X, same expression we are using. R1 and R2 are the register, M is the memory location. Now add R1, we are adding this A plus B to R1 register. Similarly, C plus D to R2 register. Now this multiplication operation done inside the destination is X. Okay, X operand. See, R1 and R2, here is the multiplication and it will be stored inside the MX location. Thank you for this session.